Did you know that mathematicians invent their own numbers all the time? You've probably heard about imaginary numbers, right? This weird fake number that squares to -1. Well, at some point that was invented. And actually, if you take an abstract algebra class, you're going to invent numbers all the time. For instance, say you're working with the whole numbers. There's no whole number that's going to square to give you exactly 5. But what you can do is you can just say, I want one, and let's call it a. And so we're going to call this number a, and a has the property that if we square it, we get 5. And what we can do is we can do a lot of math with that. We can say, well, if that's true, then now I can actually factor this polynomial as x plus a times x minus a. And so now that gives us more flexibility. We can ask new questions. How is this number system the same or different than the one we started with? What happens if we adjoin the square root of -5? What happens to things like primes or factorization? And we get lots of interesting answers. In fact, what we can do is we can see if we can try and break this system. So what if I said I really want a number a, and I want it to be a solution to this equation up here? Well, we can do that, and we can add that rule to our system, but you may have noticed that that equation actually already has two solutions that are already integers, right? The numbers 2 and 3 are both solutions. Well, that's okay. We can do that, and in fact, if you analyze this system, what you will see is that since we already kind of had two things that a could have already been, actually what we've done is we've made two copies of our number system. And there's actually a way to make this really rigorous with something called maybe the first isomorphism theorem, which is really a special case of the Chinese remainder theorem in this context. Lots of really cool stuff.